Hello everyone, my name is Kraidi and my presentation today is about making qualitative analysis of the delay factors in oil and gas pipeline projects in Iraq. I'll take you through introduction, problem statement, aim and objective, risk management framework which has been developed based on the finding of questionnaire survey, fuzzy inference system and the cases to the project, conclusion, limitation and future work. Delay is one of the most common problems in construction industry, not limited to one type of project, not limited to a country, not limited to a region. Understanding the risk factors, understanding the delay factors, identifying them, analyzing them as accurate as possible during the planning stage could provide us with the data or provide the stakeholders with data that needed to be for proper planning or proper risk management during the planning stage in order to avoid or minimize, which is better, the construction delay. When it comes to the limitations, we have found that the existing studies are limited to analyze the risk factors in one project or in a region. However, we can't use this in another project because the risk factors, for example, between the bridge projects is different or highway projects is different from the oil and gas pipeline project, or the risk factors in the UK are different from the risk factors in the Middle East or in Iraq, for example. As well as if there is no enough data about the risk factors, the existing risk management framework aren't really effective of analyzing them. Moreover, building the pipeline project without analyzing the risk factors in the planning stage would obviously cause construction delay, which cause cost and time overrun, or interrupt the supply chain of the project. Provide a good knowledge about the risk factors, analyze them as accurate as possible during the planning stage is an effective method in order to, I won't say avoid, but I should say minimize construction delay. Therefore, this paper is focusing on analyzing and quantifying the delay in the construction in oil and gas pipeline project using the finding of the literature review, questionnaire survey, fuzzy inference system or fuzzy logic theory, Monte Carlo simulation and Latin Hybrid Cube simulation in Astapollo project as a rational way of analyzing the risk factors. This is our framework that has been developed because there is no available data about the risk factors in the project. We started to identify the risk factors and using the literature review. 30 risk factors were coming as a result of the literature review. Then we started analyzing their probability and severity levels using a questionnaire survey. The finding of the survey were used as input for the fuzzy inference system in MATLAB that uses the fuzzy logic theory to analyze the risk factors. The risk index, which is the degree of impact of the risk factors on the project, were used to rank the risk factors. Then we use the risk index, the activities from the project, allocate the risk index and the activities together. That will be explained in details in a minute to calculate the total risk and the level of risk in each activity. These findings were used also in Monte Carlo simulation and Latin Hybrid Cube simulation as to analyze our calculated delay in the project. And in next slide, the details will be more clear. Now, this is the top 5 risk factors. The probability and severity levels is what we want as input for the next stage. The result of the questionnaire were reliable because the Cronbach alpha was above the value of 0.7. In order to reduce the uncertainty that results from the scarcity of data or the stakeholder judgment or the personal judgment about the stakeholders in the questionnaire survey, we have used the fuzzy inference system, which is fuzzy logic theory. The fuzzy logic theory is using intervals rather than existing values, like for example very low, or high, very high, which is the accumulation, like the intervals and the interpolation between this and the aggregation as a result in the risk index, which is the value what we need to analyze the impact of the risk factors on the project. The results of the top and less impact risk factors in Iraq, and this is what we use in the next stage. Now, this is an introduction about the case study in our project. This pipeline will transport the oil and gas project from Bedro oil field to the export point on the Gulf. The length of the pipeline is 146 kilometers, and the planned duration is 1,334 days. Now, is the point where you are using the findings of the questionnaire survey of fuzzy logic theory to allocate the risk factors to the activities of the project. Both of the questionnaires, literature review and industrial experience and industrial knowledge were used to allocate the risk factors to the activities by adding the value of the risk index to the activity. That means that this risk factors could affect the duration of that activity based on the type of the activity and the risk factors. Some of the activities got 30, for example, 13 out of 30 risk factors, or 25 out of 30 risk factors. By calculating the summation of the risk index values of the risk factors allocated with the activities, and calculating the results from out of 100, we are classifying the levels of the risk, the level of risk in each activities into 5 levels, which is, for example, from very low to very high. And for example, the activities with very high level, it could affect the duration of the project between 75% to 125%. This is what we are going to use in the next step. And this is the result of the first activities. Now I understand the level of the activity, the level of risk in the activity. I obviously know the duration of the activity which I calculated on the project, and I link the risk factors all together. Then I link this, use them as input for the Power project, then selecting what type of simulation that I need. The method of simulation is either Monte Carlo simulation or Latin hypercube, or and as well as the distribution method, which is one of these 4: uniform, normal, skewed, triangular. Then choosing the iteration number, which is 10,000, and these are the result of Power project. The difference between the original plan or and the duration plan, which is 1,334 days, is the delay here. This is the duration after of the project after calculating the impacts on this factor on this. They are different based on the different simulation and distribution method, but the difference is really minimal, which is enhancing the result of the project. The standard deviation, which is really low, out of 10,000, 18 is really a low value. The project has 50% of probability of finishing within the mean duration, 68% of finishing within this range, or 95% of chance which is finishing the project within this range. The maximum hits, which is how many times that the project that were coming this result as the duration of the project out of the 10,000 iteration number. This is an example. The mean duration got the 50%, and the standard of plus minus the standard value, the standard distribution value, which is the 68%, and the duration of the percentage of 95%, which is plus minus the value of the two standard deviation. Now, when it comes to the conclusion, the questionnaire survey were reliable and provided accurate or more realistic input for the fuzzy inference system, which uses to enhances the result and reduces the uncertainty that comes from the array of data about the risk factors. The stakeholders, the designers, the planners could use the result to understand the situation for a better plan or better estimation in their project, as well as the way of analyzing the risk factors is our rationality in this project. When it comes to the limitation, as the Power project, we could use only one distribution method at a time. However, the risk factors and the activities have different impact and different distribution on the project. In the future, we can use at-risk to overcome this limitation. Thank you.